let's compare 3 carbo-bases. Which is the strongest base? Acetate, ethanoate, or carbonate? And here I've written their structures, acetate, ethanoate, carbonate. Among those 3, which is the strongest base? Think about that for a minute and make a selection. Let's look at a possible explanation for each answer. A, acetic acid is the weakest acid, so it has the strongest conjugate base. B, ethanol is by far the weakest acid, so it should have the strongest conjugate base. And C, carbonate is doubly ionized, so it should be the strongest base. Think about those 3 and make a selection. We're talking about 3 bases: ethanoate, acetate, and carbonate. We want to know which is the strongest. When you're thinking about bases and their strength, the easiest thing to do is look at the conjugate acids. Find the weakest conjugate acid, and you'll find the strongest conjugate base. So I'm going to convert these 3 back to acids, adding a proton back, and I'm going to say, among these 3, which is the strongest acid? Well, what's going on here? This is a sequence where the oxidation number, the oxidation state of the carbon is changing. I'm adding more electron withdrawing oxygens. So the acid strength should change. And indeed, you can calculate the oxidation number of this carbon, and that's a good exercise. You can draw those Lewis dot structures and remember how to calculate oxidation numbers from Lewis dot structures. If you do, you'll find the oxidation number here of this carbon plus 1, this carbon plus 3, and this carbon plus 4. The higher the oxidation state, the stronger the acid. So the strongest acid here, the weakest acid here, and the weakest acid will have the strongest conjugate base. In this case, the answer is B, ethanoate, the strongest base.